All right, the other things that are on the calculator portion of the final, you have to be able to find the magnitude and direction of vectors. So given the components, the x and the y component, you need to be able to find the magnitude and direction. So to find the magnitude, remember the magnitude is the length. So after you draw, this is 3 over and 4 down, you're looking for that r value. That's the magnitude. So it's always, r is just going to be the square root of, in this case, 3 squared plus a negative 4 squared. Or, with this one, it's pretty easy to know that's a 3, 4, 5 right triangle. R is 5. And then to find the direction is the inverse, the theta is the theta, and it's just inverse tan of y over x. So again, you got to be a little bit careful. So when I drew it, I went 3 over and 4 down. That is in the principal value of inverse tan, so I don't have to do anything with this theta when I'm done. So if it was in the second quadrant, then I would have to add 180 degrees. So you got to be careful what your answer is. Make sure it's in the correct quadrant. So with this one, I did inverse tan of negative 4 divided by 3. Make sure you're in degrees, and I got negative 53.1 degrees, and I'm done. Now just to show you the difference, if you go over here, once you found r was like 5 square root of 2. But then when you find your angle, now you're going 5 to the left and 5 down. So now, once you take the inverse tan, you'll get an answer. Well, I guess I knew this one. It could be non-calculator. Even if you use your calculator and did inverse tan, you would have found out the calculator is going to give you 45 degrees. Because you really have an inverse of a positive, because you have a negative over a negative. So the principal value for inverse tan when it's positive will be here. Then you have to add 180 degrees, or in my case, I added pi. So just be careful on these problems. If you're over here in the second or third quadrant, basically you're just know that you have to add pi to get to those. Okay, and then what else is on the calculator part? The projectile motion. We did decide what we're going to do with that projectile motion, though, is we not only give you the formula, but we're actually going to give you, with the situation we give you, we're going to actually give you the set of equations. So you don't have to be able to plug those in. We'll tell you x equals 140t cosine 22, y equals negative 16t squared plus 140t sine 22 plus 5. We're going to give you that. You just have to be able to use it to answer these kinds of questions. So the one I circled was C. If we asked you to find out how long the ball was in the air. Okay, so if we think about a projectile, you know that, okay, it's starting here, it's going up and coming back down. I want to know how long it's in the air, so I want to know when it hits the ground, when the y value is 0. That's where you find out how long it was in the air, is you're looking to see what's the time when y equals 0. If they ask you for maximum height, you're looking for the vertex. So then you use the formula, the opposite of b over 2a, to help you find out when it hits the highest point. So you either could be asked, when does it hit the maximum height? And if you do get asked when, there might be, say, how high, so then you have to plug that number back in. So you could find out the time it takes, and then you could plug that in to figure out how high it goes. Or it's going to ask you how long it's in the air, which means then you set your function equal to 0. So you're setting your y value equal to 0. When you do that, you have to use quadratic formula. So you need to know the quadratic formula. It's the opposite of b. Our b is kind of ugly, but it's just negative 140 sine of 22, plus or minus that same value, b value squared, minus 4 times a times c, all over 2a. And what I would suggest you do is actually figure out what do you get underneath that square root sign first. So I did that and punched on my calculator, make sure you're in degrees, and I got underneath there, I got 3070.5. That's just what b squared minus 4ac. So then to find my answers, I need to take negative 52.44 plus that square root, hit enter, and then divide by negative 32. I got negative, I can't read it, 0.09 I think, but it's a negative time, doesn't work. So then I took negative 52.44 minus the square root of that, hit enter, divided by negative 32, and got 3.4. So it's in the air for 3.4 seconds. If I asked you how far it travels, Now you have to take that time, because now I need to know what's the x value when it hits the ground. So I know when it hits the ground, I put that time in to the x component to find out where it hits the ground. So that's kind of a two-part question. When does it hit the ground? Set y equal to 0 and use quadratic formula to solve for t. Where does it hit? Now you take your answer from that, the time it's hitting the ground, and then you plug that into x to figure out how far it went in the x direction. Okay, so that's the parametric. Then the conics. First of all, there's a couple questions just in general form. You should be able to look at that and tell me that's a hyperbola because there's a minus sign in between the squares. If there's a plus sign and the coefficients are the same, then it's a circle. If these coefficients were different but both positive, then it would be an ellipse. And then if only one of them is squared, it's a parabola. So make sure you know when it's in general form like that, what kind of a figure it is. Then you also need to be able to complete the square. So we could look at 14 maybe to complete the square. You group the x squared and the x term together, group the y squares, and this one doesn't have one. Put the y squared out here, get that constant over on the other side. So we added 4. And if you notice up here what I did, you didn't have to do this, but I went through and divided every term by 5 before I ever got started. So if you see there's something common to all the terms, I would do that. That's not always going to happen. Like up here, that wouldn't happen. So then you have to factor out the 16 from the x squared and the 64x. You have to factor out a negative y from the y squared and the negative 2y. So sometimes that's not going to work. This case, it worked that I could divide by 5. But then to complete the square, remember, after you get these grouped, take half of this coefficient, which in this case is 1. 1 squared is 1. So if I'm adding 1 here, there's nothing out in front of the parentheses, so then I just need to add 1. Remember, if there is something out in front of the parentheses, so if I added 4, now realize I added 4 times 16, so now over here I have to add 64. So you do have to be careful. Like here I added 1, so what I really added was a negative 1, so I have to make sure I add a negative 1. So you do have to be a little bit careful about that on some of those. Once you get it into this form, then you should be able to tell me the center. So this one's negative 1, 0, and a radius of square root of 5. Now in the final, we're really not going to make you do that. You just need to be able to get to this step right here. You need to be able to get to that general form or standard form. And then the last thing is making sure you can do partial fractions. So remember, you have to be able to factor. So I did factor this one. I took out an x, and then I factored that. And then you just need to know how to set these up. So if it's a linear factor, which both of these are, then you're using single letters. So you've got a over x. This factor is squared, so I'm going to do b over x plus 2, and then c over x plus 2 squared. If that one wasn't squared, I would only have the 1 to deal with. If it would have been something like a factor of like x squared plus 2 squared, then remember, because the factor is not linear, I would have had to set up ax plus b over the x squared plus 2 to the first, and then a cx plus d over that factor that's not linear squared. So if the factor isn't linear, then you have to put a linear on top. So if that is a quadratic, then you have to put a linear on top. If it's duplicated, you have to do both of them, to the first and to the second. But in this case, the factor was x plus 2. That is linear, so now all I have to do is do b over x plus 2 and c over x plus 2 squared. And then to solve it, we'll give you one that won't be too difficult to solve, I don't believe. But once you set this up, don't forget you're always looking to see what do I need to multiply this denominator by to get to this denominator up here. So I had to multiply by x plus 2 squared. This one I had to multiply by an x and an x plus 2, and this one I just had to multiply by an x. So I did that over here. When you get your system of equations, it's just a matter of using elimination method to do that. So I'm hoping you're okay with that algebra piece. So test tomorrow on the calculator part. All of what I've said in these two videos, that's what's on the final. Good luck!